Hello everyone, like being back in lockdown. This is teaching you from home. I just thought this was easier than showing you all at once, which would have been very hard in class. So what we are doing for science today is we are going to be testing which of our magnets is the strongest. We might have to take it in turns with which magnets we use because I haven't got loads of all of them. But let's introduce you to the magnets. So we have a small horseshoe magnet, a large horseshoe magnet. I'm going to call these rod magnets. I can't actually remember the proper name, but they're kind of like a rod. So we're going to call those rod magnets. And then we've got a large north-south magnet, a small north-south magnet like some of you were using last week, and I'm going to call this an up and down magnet because instead of having the poles at each end, north and south, it's actually got them on top and bottom, so it's a bit different, that one. Okay, and we are going to be working out which one is the strongest magnet. Okay, I'm going to pause this video now when I'm back in class with you, which is kind of weird to be saying when I'm in my front room right now. Pause this video and say to your partner, how am I going to test which magnet is the strongest? Who can think how we can test which magnet is the strongest? What will we have to use? What apparatus, that's the things we use, will we need apart from the magnets? And how will we keep our test fair so that we know each time that it's the magnet that's making the difference and nothing else? Talk your two partners again. 1 star to anyone who mentioned magnetic field, anyone that mentioned using a ruler, or anyone that mentioned having to keep something the same every time. And as seeing as, smash bang wallop, seeing as we are changing the magnet every time, what do we need to keep the same every time? Talk to your partners. Well, it would be a good idea to keep the ruler the same, wouldn't it? Just so you're using the same measurements. I'm going to use centimetres here. I've got inches on the other side, but we don't really deal much with inches these days. So I'm going to use centimetres. That you start at the same point on the ruler. Where it starts, or at the end of the ruler, that doesn't really matter. It's better to go from where the measurements start because you're more precise. What matters is that you start at the same point every time when you're measuring. What are we measuring? Probably the magnetic field, like we did a few lessons ago. What else do we need to keep the same? The thing that we are pulling in with the magnets. I'm using this little spring here. If I used something different each time, how would we know it was the magnets making the difference? It might be the metal thingy. So, keep the measurements the same, keep the method the same, the way you do it, keep the thing you're pulling in the same, only change the magnet you're using each time. I'm going to keep a table of results. I'm only going to do this for the first 2 magnets because I don't want to give the game away to you. I want you all to make a prediction before you do this test of which magnet is going to be strongest, which one will have the largest magnetic field. I almost forgot, before apparatus I should have my prediction. That's what I think is going to happen, which magnet I think will be the strongest. I'm not going to fill anything out for that because I don't want to write or say what I think will be the strongest magnet and then you all copy me. I want you to have your own ideas about that. I want you to think about it. So in any case, you might end up copying me and I might well be wrong. So prediction is just what you think might happen. You may be right, you may be wrong. We're doing the test to find out, aren't we? So it's not like we know, we're trying to find out. Okay, I've started my investigation, my writing part of it. So we nearly always start an investigation with a question. What are we trying to answer? What I'm trying to answer is, which magnet has the largest magnetic field? That's what we're trying to find out. Then our conclusion at the end will hopefully answer that question. I list my apparatus, that's the things that I use. So I listed all the different types of magnets. And what have I not added? I've not added ruler and spring. Okay, and I need a full stop there, don't I? When you write it up, you can just put various magnets because we're going to have all the magnets listed in our results table anyway, and then just put ruler and spring at the end. Okay, so that's what I'm going to use. What am I going to do? That's my method. I'm going to place magnets at 0 centimeters on a ruler and measure how far away a spring has to be before it no longer gets caught by a magnetic field. And I'm going to write results here, and I'm going to draw a little bit of a table for you to see how we lay out the results once we've done it. Here's my table for when I've done the test. So results, and I've just split this into two. So line down the middle, lines across. At the top I say what is going to be below it. So I say type of magnet here, and here are all my different types of magnet. And then the size of magnetic field, I will be recording my measurements there. And underneath that, I've got my conclusion. My conclusion is my answer to the original question, which is, which magnet has the largest magnetic field? So once I've done my tests, I've taken my measurements, recorded them here. The one with the biggest magnetic field, I can put as my conclusion. I can say which magnet has the biggest magnetic field. I could also say which one has the smallest, if I wanted to add that too. Right, time for the test. Okay, as you can see, I've lined the magnet up. I'm starting with the north-south bar magnet, the large one. Lined it up perfectly with 0 centimeters. And what I'm going to do is take this spring and I'm going to put it at different distances and see where it no longer gets caught by the magnet. We've done that before, haven't we? But this time we're going to be doing it with different magnets to measure which one has the largest magnetic field. So it's really hard to do this without my hands getting in the way so you can still see. But what you can see here is at 3.5 centimeters, there's 3, there's 4, it's halfway between 3.5. It's not pulling it in. If I just touch it a little bit closer though, there you go, it gets it. So it was just slightly less than that. It was about 3.4 centimeters. That would be 34 millimeters, wouldn't it, for all you measurement fiends out there? So 3.4 centimeters was the magnetic field for this one. And then we're going to test the other ones, record them on our sheet. So I can put for that one, large north-south bar magnet. That was, I'll get rid of that spring, 3.4 centimeters or 34 millimeters. It's a good idea if you do this in pairs because one of you can be holding it and the other one can be looking at the measurement really carefully. Pretty difficult to do on your own because, believe it or not, although you've just seen that once, I had to try doing that about 12 times because my hands kept getting in the way. All sorts of things were going wrong. So it's a good idea to do this in pairs. Record the results of each different magnet. Make sure you use the same metal thing time after time. Use the same ruler. Start at the same point in the ruler. Then when you've seen which one's got the biggest magnetic field, you can write your conclusion on your page and tell me, and we can share results, what fun we're going to have.